Hello everyone, and thank you for joining the latest Ontotext webinar. My name is Yasen Stoikov, and I want to welcome you all. The session today is with the topic Effective Sanctions with Ontotext, with speaker Peo Popov. Before we move on, I would quickly introduce him and go over a few housekeeping details that I think are important. First of all, the introduction. So Peo Popov joined Ontotext after years of successful work at IBM and CEP Bulgaria. He is a legal counsel with strong IT background, specializing in business development, intellectual property, and technology-related contract negotiations. Soon after joining Ontotext, he took the role of Director of Financial Services, where he is combining his organizational skill with his extremely accurate business flair. And by doing so, he helps our customers find the solutions they need. With that, I will quickly go over the housekeeping details. So first of all, this session, as always, is being recorded, and a link to the recording will be available to you by a follow-up email that we'll probably distribute tomorrow. Currently, you are all muted, and this is mainly to avoid background noises, but also to enable Peo to present without any interruptions. This, however, doesn't mean that you cannot communicate with us. No, you can still ask questions using the question box in the GoToWebinar panel. We actually encourage you to ask any questions that you might have, because we have planned a 15-minute Q&A session at the end of this webinar, in which we will try to have a discussion. So if you have any questions, go ahead, write them in the question box. And with that, I think it's a good time to give the floor to Peo. So Peo, the floor is yours.
Thank you very much, Yasin. Well, hello everybody. I'm happy that you choose to spend your time with the webinar of a very interesting to my heart topic. And yeah, let me go over slides and start the quick introduction. The point would be able to give a brief theoretical or conceptual overview, and then go over and do a demonstration, which show actually the data and the technology in action, so you have a first-hand understanding how does it work together. But let's start with the general introduction. So who we are. We have been doing what we are doing for a while. We are a very well established semantic technology vendor. We are also doing really good. Most of our revenue comes from multinational companies. And we are very proud to have as a publicly named customers one of the most knowledge intensive enterprises. This means data, content. We have the unique capability to combine data and content into what nowadays is called knowledge graph. And this finds application in various industry, amongst which are the financial services, healthcare, life sciences, a lot of publishing, government, manufacturing, basically across the board. Since we have been doing this for a while and we are a leader, we are membership of all worthy organizations that are interested in contributing to the development of state-of-the-art. And we also have a lot of partners providing complementary technology services solutions, and in nowadays examples, data sets, because the focus of this presentation would be the sanctions data. So what we are good for. Here's the reference use case. When it deals with big graphs, a lot of metadata, we talk hundreds of millions and billions of data, which is heavily interlinked across various of sources, and a lot of unstructured information. This is Ontotext. When you need performance on top of this data, are measured by, well, these are quite old query performance characteristic, but a lot of read, writes, updates, a lot of searches, reasoning. Well, this is again our best positioning. When you need to actually ask your data interesting question, like dealing with text and graph analytics, like the ones that we're going to talk about, extract new entities and facts from text, retrieval of similar entities, automatic classification, we would not cover today, but we'll definitely cover the next one, which is relevance and importance ranking. This is again us. and this all is beautiful from functional perspective. However, what actually matters on a day-to-day basis is being able to ensure resiliency in the operation on like a really enterprise setup, but with yeah, commodity hardware, I would say. And the second big aspect is to be able to ensure data quality with its various aspects. So if you have a situation which resembles the reference use case described on this slide, yeah, this is probably us, and we are well positioned to handle this use case. And yeah, let me start with the typical use case in the financial services industry. And I would argue that yes, sanctions, they are now mandatory for everybody, but this is, yeah, usually stems from the financial service industry as it's on usually on the forehead of the sanctions policy. So what we're going to talk about today is mostly in this central block, which falls under regulatory and risk. Nowadays, it's much more political, but to the strict classification of use case, we're going to talk about sanctions. We're going to talk about some know if your customer. This is, yeah, touches on the anti-money laundering, but also the other big use case which I see in application is risk management. This is basically third party, let's say counterparty risk management, and also something which would touch on marketing intelligence, like a company and yeah, perhaps even sector intelligence. So this is what would be the topical from the use case perspective, what we're going to be covering, the capabilities are mostly relevant for. So with this, I'm speeding up a bit because I'd like to go to the interesting part, and this is perhaps the substance of the interesting part. Well, we are talking sanctions and we're talking about better risk management. How does the strategic objective and the business requirements for better sanction screening and improved risk management look like? Well, the strategic objectives are clear. Each, like it was previously financial institution, nowadays it's many more, have to demonstrate ongoing regulatory compliance. This is one. The second mandate from this is since the role of sanctions and the role of political risk has substantially increased in the last months, I would say, the risk management practices and the risk identification and management practices need to improve also substantially. And this is also yeah, a good ground for general improvement of the entity data management as a shared critical data element. What do I mean with this? That all the use cases which I touched upon in the previous slide, be it sanctions, be it know your customer, being company intelligence, like for all of them, people, organizations, assets, location data, these represent critical data elements. And if these critical data elements are reused in so many use cases, it is a requirement, strategic objective that the management of these assets first should be substantially improved, but second, they should be treated as something which is shared among business lines, activities, and across all the operations of a company. More specifically, to avoid as much as possible creating silos of data which do not talk to each other, since we are going to end up with replicating, inventing the wheel in each system. So how these strategic objectives translate to very high level business requirements. So in order to be able to identify sanctioned entities or manage the risk, you need first to be able unambiguously to identify these entities among the potential counterparties. This means existing, let's say, customers or potential customers. We need to be able to understand who is who among the current assets. Okay, we'll be able to identify the entities of interest, but it's also a business requirement to identify all the people, organizations, and assets which are related to these assets. For example, if we're able to unambiguously identify a company, okay, we need to know all the officers of a company, all the owners of a company. We need to be able to identify the the child or the companies which they control, or the key assets which are controlled by these assets, because in the way that actually the risk and the sanctions mandate, it's put in a quite broader language. So you need to create a larger network to be able to assess the risks associated with a party. This needs to be done both against structured data. This is, let's say, your accounts, which are in the CRM, or perhaps in unstructured information. This would be, let's say, your contracts, which are in a more of a free text form, or in a news event, which might change the risk opportunity profile of a customer. So you need to process different types of content. A very typical requirement is that you need to ensure privacy of, let's say, the accounts. It's very typical for financial services industry when you're unable simply to use a third-party service and ask him about information of a party. We have a lot of requirements related to access to systems and data, which are very security and privacy conscious. The number 5 requirement is also very interesting and especially relevant for large enterprises which operate in various jurisdictions. This needs to be, the requirement is often referred to as a Rosetta Stone, because if you're dealing with a multinational company, you need to ensure compliance not only with your home jurisdiction, but you need to ensure compliance with all the jurisdictions mandates which you're operating in. And for example, if you have a company in Switzerland, you have to ensure compliance with the Swiss regulations, but they might not be the same as the US regulations. Some other jurisdictions might have different or more relaxed or even contradicting requirements. And you need these Rosetta Stone, or if you will, views on top of your data in order to understand what is your compliance requirements. The sixth one is a general one, and it's enormous, that you need to maintain first a complete and an up-to-date information about entities. You follow the news and you know that new entities are added to the sanction list almost on a weekly basis nowadays. So you need to be able to up-to-date, but you need also to be able to identify as much data about these entities as possible. Then you have the interoperability of your assets, because first it needs to be used by various internal systems, but for many reporting and compliance purposes, interoperability with certain standards and formats is also required. This is also relevant to number 8, which, as I try to describe in this strategic objective number 3 here, they need to be consumed by different applications. And this also means that when you are managing your entity data as one, like in one enterprise knowledge graph usually, then you need to ensure constant enriching of the existing data by leveraging third-party resources to be able to add additional information or to be able to keep up to date your current existing data fields. Operational resiliency is, let's have this as a foundation for all the non-functional requirements which need to be ensured. They are like a story on their own. And of course, the last but not least, these are only example business requirements. The data is going to be used by various stakeholders. First, there perhaps are going to be the information architects who would care about the data themselves. Then the solution architects, the people who are more software minded, would come into mind. Then there will be the developers. Then will be, let's say, the data scientists. I'm sure that there will be business analysts like of personas, and all of these stakeholders have their own requirements. So your data should be present in a convenient and accessible form for all of these types of stakeholders. So it's typical. It starts small from a simply compliance with, let's say, a sanctions list. But if you have to approach this in actual enterprise manners, this is only, I assure you, just the beginning of the type of requirements that you are facing. So How does we deal with them on like a technical basis? Nowadays, a modern paradigm is organizing your data is like creating a data fabric. I prefer the second, which is a data is a product, which is like another way to say like you treat your data as the main asset of your organization. This is the long spoken transition from being a software company, from being, let's say, perhaps a content company, to being a data company. If you treat your data as your main assets, if your architecture is first data centric, your focus is in improving your usability and the quality of the data. And this means, amongst other things, extend and enrich, express and share the value and the meaning, expose interfaces. Again, resilience is key here. And these capabilities are manifested in a very, these are a bit more detailed capabilities around ingestion, modeling, consumption, operations, and yet some typical usage scenario, which these are like here are the first usage scenarios that we usually hit in a deployment. But I wouldn't cover this in a detail because these are quite general and they're specific to each use case and implementation. Okay, we are moving towards the actual challenges and the solutions which we are going to discuss today. What are the typical challenges to being able to, let's say, to ensure efficient entity identification, both in structured data and in free-form, let's say, textual data? To any natural language, the challenges which it poses are ambiguity. Natural language is tremendously ambiguous. With the data volume is the second one. Here is when we speak about large data sets, and it's almost the proverbial needle in a haystack problem, always. Inconsistency, so many forms of inconsistencies. I wouldn't also, I hope that you're sufficiently experienced. So when we speak about data inconsistency and variability, this is scary stuff. If you're not scared, you're not experienced enough. But we can do better, and we can achieve better outcomes by, let's say, the first and the foremost thing is to be able to convert strings to things, to be able to unambiguously identify concepts of a certain type. This is a bliss for the machines. So this is why, like I posed it the first time, and this is why I'm going to focus on the reconciliation capability and entity identification in a larger sense. And then on the second part of this presentation, I have created a very speculative discoverability diagram that in order to achieve the proverbial 100% correctness and discoverability of an entity, what are the technologies which are contributing? And they're listed here in the bullets too. So the first method for discovery of information, this is search. This is everything which you're familiar with thanks to, let's say, Google, who taught people when they're looking for a piece of data to start typing and to expect automatically their responses delivered. So this was, back in the day achieved by full text indexing, was the tool of the trade which helped us achieve these results. And by this, I also cover various variations in spelling, multilingual support. This is, a lot of indexing on a full text basis, which we have done. But in my very speculative discoverability index, I would say that close to, let's say, 40% of the good and scalable full text indexing, like the best Lucene-based engines like Solr, like Elastic, which we're going to use later, this is what they're able to achieve, around 40% of this, let's say, discoverability phase. Then a lot of has been improved by introducing semantically typed data. I'm talking about here, an example is to be able to specify that what I'm looking for is an organization, and it's not only any organization, but it's a company, and it's not any company, but it's a public company. So this is type data, which enables me to narrow down whatever I need and to this way improve the discoverability. that it's not simply a person, it is perhaps a woman who has a nationality, let's say she's British. And this introduction of the semantically typed data, when combined with the full text indexing, it's also known as faceting, it's a great deal of improving your discoverability of your information. So in a typical sense, like if you're able to do a good fast search, let's say, on top of your, let's say, content, you have achieved a lot. But have you achieved enough? Well, typically not, because we can do more and we can do better. We can definitely introduce ranked results. And in our case, since we are graph experts, we are best in using ranking based on graph connectivity and structural similarity. This is, yeah, something which everybody who has dealt with search would tell you that every user respects the autocomplete to be able to present him with the first or second option what he is looking for. This is the only search that is usable. And ranking is the key, the ability to, yeah, show the most relevant result first. And then I'm going to, like I have shared the actual embeddings types of presenting a new way of search, a new way of indexing the information, which has actually improved the discoverability quite a lot. And it's yet another indexing in search paradigm. And my, like the point of my demonstration here would be that if we're able to combine all these techniques in our, let's say, search, identification, information retrieval, however you want to call it, application, then we are closer and closer to the proverbial 100% of discoverability, or like a perfect entity identification in our case. And yeah, the focus of the demo part of this presentation would be to showcase how with the model, the data, and the underlying graph database that we are demonstrating this, we are getting closer and closer to this perfection. So the demonstration that I'm going to do, first I'm going to introduce the data set itself and the model. Then we're going to talk with the very trivial stuff like autocomplete, rank. Then we're going to do with some full text indexing, reconciliation. Yeah, it would be boring if always technical, so let's do some visualization. And then we'll go about a bit more advanced stuff like the semantic indexing, the combined indexing, and some text analytic as for a finish. So this would be the table of my demonstrations. Now I'm switching towards my browser, where Yasin should have shared in the chat a Google Doc which is public. Yasin, I'm sure that you've already shared it. It should be in the common chat. So the point of this document is to serve as notes accompanying the webinar. You, when you open the URL, you would have the right to comment here. And please do comment, do ask questions, because this document contains a lot of links, a lot of queries, a lot of simple notes, examples, links, everything which I find to be somehow relevant to the topic of nowadays presentation. However, I would physically not be able to go into all these notes in details. I would not be able to write these queries down for you. I would not be able to cover the links which I would like to cover. So please go to the document, take a look at the structure. There would be stuff missing, there will be wrong stuff, but please, the idea is that it is something like a leaflet that you would have, which would be hopefully helpful for you to reproduce the examples. And here is René Descartes, who is actually one of the guys who formulated one of the biggest challenges that we're going to face today. This is the Cartesian multiplication, the Cartesian products, which makes it especially hard to do, let's say, record linking. And one of our ambitions would be to be able to reduce the complexity of the problem that this gentleman in black figured out. So when we should start from? Actually, I would like to give you should start from the model. This is actually the first thing. The model that is used the open sanctions data, which I cover perhaps in a moment, is mapped to the follow the money model. This is actually all the result of the efforts of a great team which started with the OCRP, Investigative Journalism Consortium, who developed a software for investigative journalism called Aleph. And they have mapped their data to the follow the money data model. And it's a very interesting data model, which I'll encourage you to follow the links and look in detail, because it is created to be able, as one of his co-inventors called it, to enable conversation on top of some data. But if we would like to be able to give a more formal understanding, here is the actual visualization of the model. You have a link in the notes, and you would find that it's a very, very complex model. It is centered around entities. They, in my view, are a bit ambitiously called legal entities, which talks about people and organizations and all the relationships to other classes of this model. And in this case, like legal entity has interest, they would have some events. These are like two key elements in the model. They are entities and intervals, which means the time-bounded interest. But you will see that like a legal entity, it has membership, it has a directorship, it is also related but to organization. There is an employment to the organization, and you can spend a lot of your time like studying and familiarizing yourself with the model. This is why in the notes themselves, I have included the link to this visualization, which you would be able to spend time on your own. The point here is that, as with any semantic technology, as a backend, it has a conceptual model which helps explain the data that it represents. And the second thing is the actual data. Here is the Open Sanctions website, and it's the tremendous work of, I believe, no more than 2 people who have done the excellent work of creating different lists and set of lists to be able to enable companies and journalists to explore the different entities and relationship between them. So I would strongly encourage you to take a very detailed look to this website, because it has much more than sanctions data. They are gathered, the large group of interest is gathered in these what they're called collection. And now today we're going to deal only with the sanctioned entities, but I'll definitely encourage you to take a look at the politically exposed people, persons. And then I have found this warrants in criminal entities to be of particular interest. Of course, if you're more of a know your customer due diligence, you would be interested in this collection too. But since we're talking about sanctions nowadays, I'm going to give you first an introduction from the website about this consolidated list and sanctioned entities. And here you have like how many targets they are. See, a lot of people, organizations, a lot of vessels. These are the most interesting entities, the vessels and the airplanes. And what is the interesting thing about the data sources? Actually, everybody who is diligent should start from the data sources. And here you recognize not only the US lists like OFAC, but you would recognize a bit of more sources which are not every day in the news. Let's call it like this. And it's excellent collections of data. And this is the data which is loaded in the database, which you see now on my screen. And the first thing which you need to start perhaps in exploring your data is, let's go with the class hierarchy. The class hierarchy is what this information is about. And here you'll be able to see, like, let's say in the general stuff of think, you're dealing with companies, with securities. Here you're dealing with airplanes or some kind of vessels. When you're dealing with things, it might be organization, or I believe this was a legal and a company. Actually, this should be this class, or people, organizations. when we're dealing with intervals, which is yeah, interesting abstraction of the model, we are dealing with representation, directorship, ownership, or some kind of membership. There are some like smaller classes here, like when I would be able employment, documentation, and this. But this class diagram, which is part of the workbench, enables exactly this, enables to take like a look at the classes of the model and explore how they are nested to each other. So it allows you to scroll amongst different level of abstraction and familiarize yourself with the general concepts. If you're willing to understand what are the class relationships, so how many, let's say, sanctions are referring to, let's say, a company, this is yet another visualization which you can get from the menu from the left side of the screen. And here you see like how the sanctions, of course, are here the central topics, but how they related to organizations, how they related to companies, or the general class of a legal entity, like how many like ownership relationships they are. Let's see here, you would say ownership relationships between an organization and a person. These are what are like the arrows here. Like here, some identification, even there, even passport details. You know, there's also address information, which is about people, organizations, legal entities in general, and so far. So this is a very interesting way to explore the relationship between the different classes of information. And with that, yeah, we'll go to the visual, but now I'm going to switch to the autocomplete functionality. The autocomplete is the foundational means of information retrieval. This is why in the it enables search, and this is why it's foundational. As I mentioned previously, this is the ability to be able to start typing and with the clear expectation that relevant results would follow. And since the war in Ukraine is in the focus of this of the news cycle, let's say I'll start with some let's say Russian companies, and here I would go and search from Vneshtorgov Bank. This is VTB, one of the largest export banks of Russia. And as expected, I have like yeah, the most relevant entity first, and I'm able to open the resource of the entity. So here I would use this as an example to see what type of information do we have in the sanctions data sets, and some of the powerful semantics which are like used by this the follow the money model. The first and the most interesting, these are the labels. This is one of the like the many names to the same thing. You would know that this is the subject is a unique string, and all these strings are identifying these things. This is the strings to things paradigm. We are able to have many names for one and the same thing. And here, whoever is yeah, contexts. So this is the richness. If you're interested in how to like to enable auto completion, you click here on the settings and go to the autocomplete, and everything that you see here that I have enabled autocomplete index, which is based on a couple of semantic fields. Like this is the preferred label and alt label. These are all alternative names which I just showed you on the screen. So this is foundational. This is base one to be able to enable auto completion index. So the other interesting thing is that we have used some inference here on the data. Even that it's not heavily modeled, you would know that the total statements in the data sets, they are a bit of like 1.3 million of statements. However, the explicit ones are around a million. And we have like 250,000 statements which are inferred, which is actually very careful use of inference here. But the great thing is that we have been able to expand the data, which is from the one which is explicitly in the data sets, in the source of data. On the basis of the logic of the model, we have been able to derive new statements, which is just a very small, like it has been increased by 24% basically, like 23%. But we have been able to generate new data and to ensure again better coverage and better discoverability. This would come to the slide which I presented. And the other thing which is important in order to be able to ensure that National Gov Bank would come first would be that we are ensuring ranks. So this is another feature which I have utilized here. And I would like just to point your attention that given that I've studied the data, I have identified a named graph which would contain mostly relevant statements for being able to calculate graph centricity. And on the basis of this centricity, I'm able to rank the most relevant first. So yeah, this is more or less trivial. And then would move to something which is, yeah, again, common type. This is indexing. Since it's a relatively small data sets, around, let's say, 1 million entities, I wanted to do something more impressive. So I am going to demonstrate creating a full text indexing or something which is a bit bigger. And here we're talking about hundreds of millions, which are expanded 2.5 times. This is the GLAIF data, which is a reference company data set. And here, what I'm going to demonstrate or just to show is the ability to create full text indices run by Elastic in this case, which are really scalable, by being able to select a graph pattern from the big graph and to expose this for search. This is tremendously powerful because for information retrieval, if search might be your main use case, but you also, in order to ensure sub-second responses, you would largely benefit from hitting an immutable structure, let's say like Elasticsearch, which gives you like a much better scalability and performance. And in this example connector, I have created index of, let's say, of the Russian companies which are part of the GLAI reference data. I would share in a minute why I have chosen this. And here it's it is as simple as being able to fill like a form like this in order to create an Elastic index. You have to fill out a jurisdiction, you have to fill out that this is a type, and you need to be able to collect all the fields which are containing the names of the company. So here you would see that I have the proper legal name. I have collected the alternative language name because multilinguality is important. I have creating trading or operating name, which is a shorter name. Previous names are also very important. This is like the case of companies like Meta, which are referred to Facebook continuously. And I have stated that the types are of a type of a legal entity. So this is come back to again to the slide of being able to use semantically typed data in order to combine it with the full text capabilities of Elastic in order to pinpoint the search use case. And it is as simple as filling a form, and we are exposing an index, Elasticsearch index, which in the next demonstration I'm going to use by a reconciliation service. And I hope now that you're able to see my terminal, which would show something which is a configuration. And I hope you like the configuration because this would be very short configuration. It is the configuration of a reconciliation endpoint. And in order to enable and to run reconciliation endpoint, it's again quite simple and straightforward. In this case, I'm talking about index containing Russian companies, and I need to call the name of the company. I need to specify where the Elasticsearch is running, the name of the field, the type of the entity, and what is the default response. And this is all the configuration which I need in order to be able to create a reconciliation endpoint. And if you see, there are other indexes or their reconciliation endpoints which I created. These are, let's say, all the ultimate parents of GLE. They're all the countries in the world. They are, I believe, I also have created a ticker reconciliation endpoint, and I might create basically as many as I like, because everything which I have to do is to fill a configuration which look like this, which works on top of Elasticsearch, which looks like this. So the components which assemble the solution on top of the data sets is first semantics, which enable me to talk with the type data, then scalable indexing with Elastic, which are getting the correct field from the graph and exposing it via the Elasticsearch interface, and then using a reconciliation endpoint, which I'm going to demonstrate how I'm going to use right now. The typical use case for reconciliation endpoint is simply try to map my own data to something which is already a string. So here is what we talk about strings. And here are the preferred labels of, let's say, of the top sanctioned Russian companies. This, like I have selected top 10 Russian companies. And I'm going to do this in front of you. I'm simply going to duplicate the company. And what I'm going to do is I'm going to reconcile the strings, which are generally strings here, to a reconciliation endpoint. And here you would know that I have registered some of these reconciliation endpoint which I have configured here. I have registered them as a services. So I might resolve this to Wikidata, to LCC countries, to GLE company, or to Russian companies, which I have chosen in this particular way. I have the types of a legal person or entity or some registered entity, which again, these types are based on the semantics of the data. I would choose no particular type, and I'll simply click on reconciliation. And here, for what has been a string, I have all the labels which are sourced from the graph, which are suggesting what would be the proper ID for this string. And it's a duplicate for this ID, and it would be the GLE reference ID. And if I, let's say, click on the, the one for, in this case, for VTB Bank, I would go to the hosting here of this data set, which would show me that perhaps this is the right data set. So I'm able to confirm that this is the right match. And in my sample here, there are some which are not or non-existent matches, like this ERP scan company, which it's missing because yeah, it's simply a data set, a company which is missing in the reference data set in GLE data sets in this case. I have checked this with Wikidata. It's also missing in Wikidata. It's a strange company. But the next one, for example, so we have to create a new item, which is okay. We have to create a new item. Reconciliation as search, as I mentioned earlier, they are not perfect. They are not auto magic. The next one is a curious one because it's definitely a wrong one. This is, I believe this was something like an industry bank in Russia, but you see that this is a clear mistake. That it should not be JP Morgan International. So this is something which is wrong, as I believe it's the next one. And here we are hitting some of the limitations of the full text search, which I indicated in my presentation here. Here we're dealing with full text indexing, we're dealing with type data. It is ranked, but it's still not good, because if in this case we have such errors like this means that we cannot automatically rely on the scoring in order to reconcile or to link our data to IDs or to do a record linking. So this is why we are going to let's continue perhaps with the toolings that we are going to explore. And the next tooling in our arsenal would be a similarity index. What is this index? This is basically a word embedding index, which uses a different indexing and retrieval paradigm in order to be able to try to produce more relevant results. So in this case, I have created an index of the Russian companies, which is an embedding index of the Russian companies. And I'm going to, let's say, try to search for, again, Sber, which is the, a common name from the Sberbank, one of the biggest banks. And here I would see like an embeddings type of score similarity, what would be the best search. And I'm able to do term to document or term to term relationships, or even document to term and document to document. But yeah, interesting thing would be what would be the most common terms which would occur in this is in the general text embedding fashion with Sber. And if you know that this is the Cyrillic name of Sberbank, it has 100% certainty this is the same, which is actually demonstrating that the embedding indexing works as expected. But it does not work as with the full text search. So in this diagram, it is something which is complementary to the other search paradigms. And now one of the interesting things which I definitely would like to demonstrate is what happens when we combine all of these: full text, type data, rank, and embeddings. And this would be done by a really sophisticated query that it's not that sophisticated. It's hard query that you have in the nodes, but you'll be able to run this on your own. And basically what this query does is as follows. The query string is Sberbank in Cyrillic. This is the query. And following this, we are hitting a couple of indices. We are hitting a similarity search index in these Russian companies. And we are retrieving via these queries, and we are retrieving the results and the document IDs, which are associated, again, with some scoring. We're also getting the legal name of the company. Then, after hitting the first similarity index, we are hitting the second, which is the elastic full search index, which I demonstrated. And we're getting also the elastic score, which we have been discussing. And this is the elastic score is almost the same as the score which is used by the reconciliation. So the results which are achieved by the reconciliation, they are mostly due to the elastic scoring. And I can spend a lot of time discussing how these indexing approaches can be improved, what can be done by better full text indexing, how the embedding indexes can be improved. But actually the third part of the mix is the RDF rank. This is the graph rank, which has been mentioned again here. So this query is an attempted mix of all these discoverability paradigms into one. And the interesting part is when I combine these results. And here you would see that I'm combining these results for the query string of, let's say, Sberbank in Cyrillic. And I'm able to combine the scores from the Elasticsearch, from the full text indexing. I'm also combining the scores of the ranking as a combined rank. And then, because I do not have a better formula, I'm combining the score, the ranks, and the embeddings scoring into one scored rank feature, which I'm using as like a ordering criteria here. And as a query, this is a rather pointless, but the demonstration is of the ability to use the different search paradigms with the same query and to demonstrate the difference of the outcomes and how these outcomes are scored. You would be able to improve each and every part of this query. You'll be able to create a better embedding index using the interface. You'll be able to create a better elastic index. You'll be able to improve the rank, and of course, the holy grail is the combination of them all. But the point here is to demonstrate how all these information retrieval paradigms are comparing with each other, because here the data is the same, but we see here that the first is Sberbank of Russia, then the legal name from Elastic is in Cyrillic. So you see that it definitely hits, if we look from Cyrillic, some of it would return in Latin name or the English name. And you see here how the typical coverage of using these combined paradigms would differ from the traditional full text matching, which is might be improved as much with all the text similarity scores as needed. But you would understand why this Sberbank of Russia would never match the Cyrillic one. And here is the manner of indexing, and of course the combination of these search paradigms. Which is one of the main things which I wanted to demonstrate in this case, because this shows the ability of the capable demonstration. And before you might ask if I would advise that you should listen to these results and automatically link your data. No. The point is to enable as much as possible to have the richest metadata for the actual record linking. If you're aiming for the proverbial 100%, this is the last mile, which I would spend hours discussing with you how it should be reached. But the high quality of the indexing and the scoring is something which I don't think that you can easily get with, let's say, these are like 20 lines of querying and basically a couple of configurations. And since I promised some visualization, let's go to see one of the entities, which again has all these data. But it's good for a change to see something which is a bit more visual. And here we will be able to take a graphy look of the data, to expand the subsidiaries, to take a look. Let's say here is the UK entity, to read a bit more about it, to click around, and basically do a bit more of visual exploration after all these indexing and hard backend stuff. So which would, I believe, would touch on the visualization part. And in interesting times, the ones who I've talked with, you know that I can spend hours talking about this, but I would like to mark the capabilities, and this is the note, the points of the notes document, to be able to enable you to get to this point on your own, so you can play in details with this functionality. And the combined indexing and text analytics would be the last one, because so far we have talked only with structured data. So I would like to give you a quick example with my favorite meme, with this example article, which is about a musician who is actually, this has been a quite old news, but still it's my favorite meme, that we are able to process unstructured text and do text analytics and extraction out of this unstructured text by sending this to a text analytics. So what we're able to do is about this person who is Rudogin. And who is Rudogin? If you haven't heard of it, I would introduce him by the means of a meme. So Mick Jagger is a rich person. You know who Mick Jagger is. Paul McCartney also is doing quite well. Bono has done best of the perhaps the modern musicians. But this gentleman here, who is a cello soloist for the Mariinsky Theater, one of the best in Russia, but still he plays cello. It could be bass. He owns 2 billion of assets. And he's beating all the famous musicians in his time. And the answer why is in this article, that which is actually, I don't know if I copied the right paragraph, but it's in the center is Putin. And let me just copy this again, because I need to include Mr. Putin himself in order to be able to recognize him. I copied the wrong paragraph. And we are able to find association. First, we're able to identify somebody who is mentioned in a text, even by a family name, but by the feature of co-occurrence, we are able to find entities which occur in one publication or another. Why? Like I'm speaking of even the co-occurrence, if not pure relationship as something important, because this was the improved management of associated entities, which are just treat them as red flags, something which imposes risks. And on the using the simplest of co-occurrences, we are able to identify that this party, even that he's a good cello player, he might be a exposed person, which we should be a bit more careful of. Here I would simply stop, because as usual I'm over time and I would rather take a look at your questions. So let me try to handle the chat now. Yaska, I have the traditional issue with the questions. Good. It's the best time to start typing down your questions. I see one from Thomas. Is there overview of the different sanction data sets which follow the money glaive and how they distinguish? They are definitely used for different use cases. Thomas, glaive is a reference data sets which is mostly used for exposure reporting purposes. It uses an coding model. Follow the money is mostly on a investigative journalism. Think of it this way. But the data entities are the same. And here, what I've tried to demonstrate is that we combine two data sets which have a totally different purpose into one via, let's say, this reconciliation, because the combination between both of them is much stronger. For example, you are getting an entity which is reported under the follow the money model. But if you reconcile it to a GLAY data set, then you know how much exposure you have to a sanctioned entity. And this is because you usually would report your exposures to the regulator in GLAY using GLAY identifiers. And this is the key. And if, let's say, a new financial institution is included in the sanctions data set, the key to reconcile it towards GLAY is crucial, because from GLAY you have all the ISINs, which are the financial instruments numbers, and the amounts of these assets that you are holding. So it's clear that you are able to get your exposition immediately. And you believe, if you think it's something trivial, I would very much willing to say it's not so trivial, because the financial crisis, the point of financial crisis has been that nobody knew what was their exposure to Lehman Brothers, and we are supposed to have improved since. But since this Archegos capital crisis happened, very few of the financial institutions were able to report their exposition toward this failing company. So as simple as it might sound, combining, let's say in our example, sanction data with GLAY data is of enormous use. And this doesn't speak to the data quality benefits that we can generate out of this. I can speak a lot of the data sets. So here, Andres Gibson, all this functionality is actually, currently I have demonstrated GraphDB only. If you're willing to enable some of the consumption endpoints, let's say GraphQL, you need the platform. If you also need to ensure some role-based access control, again, you need the platform components. So the usual, since I'm covering quite the basic scenarios here, I have stayed in the GraphDB as a product. But the role of the platform is to serve as an accelerator for all these projects. So it provides many useful components which are helpful in various cases. Again, as with any use case, we have to discuss what are the requirements, what are the features, and so on and so on. Definitely, Alex, the point here is that I keep documents for years in this case, and it's my great pleasure to see somebody who tries to use the example. And since I always just dotted something or haven't detailed the examples, people who comment on this, they help me reproduce the examples much better. So yeah, this is why it's interesting. Good. We are 20 seconds towards the hour. If there are any more questions, I'll be happy to answer them. Or like if you have anything which remarks, question, comment, something that I believe is more towards use case or your particular circumstances, please reach out. This is something which I invested a lot of interest in and effort and attention. I'm very happy to talk about it. As you see that, yeah, I'm at the time. So Yasin, or
Yeah, thank
perhaps
you
let's
very much,
call for
Peo.
questions, or let's say thank you.
Yeah, it's time to end the webinar, but if you have additional questions, of course, please feel free to just reach out to Peo directly or to Ontotext, and we will refer your question to him. So thanks again for joining, and I hope we will see you again on our next webinar or event or whatever. So bye all, and have a nice day or evening. Bye, Peo, and thank you
Well,
always also for the wonderful webinar.
thank you very much, everyone. Yeah, thank you for spending the hour with me. If you have more questions, please do not hesitate. I am deeply interested in the matter. So
All
thank
right,
you and goodbye.
bye bye.